Yes, good evening. You are welcome to my YouTube channel. You are welcome to my YouTube channel. In this video, I'll be taking you on the inner workings of PROTA structure for beam design. I'll be taking you through inner workings of PROTA structure for beam design. Some people say that the software over designs, the software is not good, the software blah blah blah. It's because they don't know how to use the software. So I'll be taking you through the inner workings of PROTA structure for beam design. So for this course video, I'll be taking you on how to design um a simply supported beam. No, rather, I'll be taking you on how to design two simply supported beams and one continuous beam. But for the simply supported beam, one is singly reinforced while the other one is actually going to be what? Doubly reinforced. And we are going to be taking our examples from engineer Dr. Victor Oyenuga's textbook. Now, let us proceed now. Let us proceed. So the first thing we are going to do, is what? I'm going to show you which examples are we going to be working on. So we are going to be working on, okay, this will be the last example. Let me show you the examples. Okay, we'll be working on this example. I will show you how to model a simply supported beam and a continuous beam on PROTA structure. So we are going to make, okay, now this is the first example. Can you see the free body diagram of a UDL of 20.5 kilonewton per meter at a distance of 4.2 meters. Now, let us model this on PROTA structure. This is the first example that we are going to be modeling. Now, let's go to the software now. Now, okay, we are the software. Now, remember that the distance is actually at a 4.2 meter. Now, if you want to model this, what you do is you go to modeling, you will click on grid. When you click on grid, draw an horizontal line, just draw an horizontal line, drop it, then draw a vertical line to intercept the horizontal line at any point, you drop it. Now, let's go to the example. The example says that it is at a distance of what? 4.2 meters. Now, let's go. So, what you do is that you will now click on this, offset, right click, then you go to offset axis, then you press Shift F2, then you now press 4,200 meters. Of course, as you can see from the textbook, it is actually simply supported. That means we have support at both sides. It is not fixed and it is not a cantilever. Sorry. So you click on column. We are not designing the column, we are designing the beam. So let's just use any section of the column. Then we are not interested in the beam sections or the beam sizes. What we're interested in is that we want to check the moment and also just check the moment, because I checked the textbook and I saw that he actually concentrated more on just giving us the result of the moment. Now, very good. Now, the next thing we need to do now is to what? Is to model our beams. Let's model our beams, because if we don't model the beam, there's no way we are going to check the moment that is acting on the beam. So very good, very good, very good. This is very good. Now, this is the first example. Let's just try and confirm. Okay, we haven't modeled the wall load on it. Can you see? Okay, very good. Now the next thing now is to what? Let's check the UDL. The UDL is what? 20.50 kilonewton per meter. That is the UDL. So let's now model the UDL now. What we are going to do now is what? Let's click on this. Let's go to edit load. It will tell us to go and select our load combinations now. Okay, very good. Now let's go to what? Loading generator. Let's click on loading generator. Now for this example, I don't want it to create factored combination. So I'll click on yes. Create unfactored G plus Q combination. So I check that. I don't want it to create a factored G plus Q. I want to use the exact value of what is in the textbook. So this one, this one, let me just change this one to 1.0. Let me make this 1.0. So I'm using the exact value of what is in the textbook. I don't want it to multiply it by any factor of safety. So we click on OK. So you can see this is what you have. Now I'm going to delete all this. I don't need all this. The only one I need is load combination 2. That is the only one I need. That's the only one I need. Load combination 2 is the only one, is the only thing I need here. Okay. Yes. Let me delete this also. Let me delete this. Very good. So you can see that our dead load, the factor of safety is 1.0, and our live load, the factor of safety is also 1.0. So that means that I need to input the exact value of it. Now remember that the UDL is what? 20.50 kilonewton per meter. So let's click on wall load. Very good. Now, this is okay. Let me explain this to you. Now. Now, let's go to the textbook. The textbook is what? 20.50 kilonewton per meter. That's the UDL. Now, for you to be able to input the UDL in the software, you need to manipulate it to get 20.50. Now, let's go to calculator. Now, remember that the unit weight of a block wall is what? 3.47 plus finishes. I've already explained in my video on the design of what? Semi-detached structure. So you have what? So then I have what? 20.50. Now for me to get the 20.50, it will now be what? 20.50 divided by 3.47. So what the software is telling me now is that I need to input what? 59077. 59077. So let's convert it to millimeters. 5908. 5908. Now let's go to the software. So let's go here. Let's go. Let's click on edit load. Are we there? Let's click on wall load. So remember what we got? We got what? 5908. Very good. We got 5908. So for the 5908, when you place it here, you see you're actually getting 20.50. 20.50, just as what we have in the textbook. So we click on this, and we now click on, then we can update. Then we'll click on what? Okay, very good. This is what we have. Now remember what I told you in my video on the semi-detached. If you have not watched the video on the design of the semi-detached, I actually explained about the fact that the default setting of the software is that all the beams are fixed, but this textbook is telling us that the beam is actually a simply supported beam. So we need to inch this to make it a simply supported beam. So what you do now is that you will click on the beam, then you go to what? Update beam end condition. They will say both ends inch. Once you click on OK, so automatically the beam is now a simply supported. So this is a reflection of what we have in the textbook. Now the next example now is that of a continuous beam. Now let's go down. The next example is what? Is that of a continuous beam. This is it. So we need to model this now. Now let's go to the software. Let's go to, please, if you have any question, you can drop your question in the comment section. And if you have not subscribed to my YouTube channel, I need you to click on subscribe, and I need you to also like. It is very, very important, because I'm gonna be like I said, I'm also gonna be teaching you how to use STAAD Pro to design some structures also. And in this my YouTube channel, I'll be teaching you how to design a raft slab, a slab raft, and also a pie foundation. That is when we get to types of foundation. Now the next thing is what? Example 2, which is this. So what we need to do now is to click on grid. Click on grid. Like I told you, just draw a vertical line, draw an horizontal line, hold down your shift key, drop it. The next thing now is to what? Is to draw a vertical line, hold down your shift key and drop it. So let's check the textbook. We have what? We have 4.2, 4.5, 4.5, and 4.2. So let's go. So let's go to offset. Then you press Shift F2. The first one is 4,200. Okay. Then the next one is what? 4,500. Shift F2. You have what? 4,500. The next one is what? Also 4,500. Then the next one is what? Shift F2, 4,200. Very good. That's what we have. So let's check here. You have 4,245. Okay. No, I think there's a mistake somewhere. Okay, this is where we are. We have 4,2, 4,5, 4,5, and 4,2. Very, very good. So we have already modeled the dimension in the textbook. Now the next thing we need to do now is to what? Is to insert our support. You can see here, as you can see here, that we have supports here. Is that so? We have it at the last place also. And the next thing we now need to do now is to what? Is to draw our beam. So let's draw our beam. Don't worry about the section. We are only interested in seeing what the moment is. Very good. So this is what we have. This is what we have now. So what we have here is what? For the UDL is what? 57 kilonewton meters. So let's try and model 57 kilonewton per meter rather. 57 kilonewton per meter. So let's come to this one now. Let's click on this. Let's click on edit load. Okay, very good. Now let us also check for this now. What we need to do now is what? 3.47 divided by what? 57. Okay, we have our calculator. So we have 57 divided by 3.47. So we have, okay, let's convert it to millimeters. So we have 16427 approximately. 16427. So let's click on edit load. Then let's go to wall load. Then let's have 16427. Then let's delete this. 16427. Okay, 16427. Very good. So let's click on this. So you see we have 57.002 here. Then we can now click on update, and then we'll click on OK. So let's copy load. So let's highlight all this, and let's right click, then let's paste it there. So very good. The same thing also, we need to hinge this, because if we don't hinge it, it will say the support at the left has been fixed. So we need to hinge it. Now let's go to update beam end condition, hinge at left. Very good. Now let's come here also, update. Let's come here also, update beam end condition, hinge at right, apply to selected beams. Very good. So this has been done. Now let's go to the last one now that I want to show you. Maybe in subsequent videos I'll show you how to use PROTA to design a cantilever beam. But let's go to, okay, this is where we are. So let's model this. The same thing also. Let's go to grid. Hold down your control key. Then let's come here. Same thing. So from here, let's offset 6 meters. So offset, right click offset, then you have shift F2. You have 6,000 millimeter. Very good. This is very, very good. So let's get our support. So let's go to properties. Let's place our properties. Then let's go to beam. Very good. Now the next thing we need to do now is to load this also. So now let's go to the textbook and let's see. We have 85 kilonewton per meter. So 85 kilonewton per meter is what? Okay, let's go to the calculator. So we have 85 divided by 3.47 is what we have, then times 1000, convert it to millimeter. So we have 24,496 approximately. 24,496. So let's go to edit load, then let's go to wall load. So let's change this to 24,496. 24,496. Then let's click on this. Can you see we have 85.001, which is what we have in the textbook also. So okay, now let's inch this also because it is fixed now. So let's go to update. So we have both end inch apply to selected beam. Very, very good now. So we have been able to model the structure the way we have it in the textbook. So now let's now see this and let us now compare our result with what we have in the textbook. So let's go to analysis. Let's go to building analysis. Okay, let's check our model. I know there won't be errors anyway. Okay, then let's go to building analysis. Like I said, we are not checking reinforcement or anything. We only want to check the moment of the beam. We don't even need to design a column because, okay, no problem. Let's just design it. So let's go to building analysis now. Let's wait for it to load. 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 Yes. Okay. Very good. Very good. Now let's go to the textbook. Let's go to the textbook and let's see what we have. Let's see what we have. Let's see what we have here. Okay, very good. Now for this, the moment gotten was 45.2 kilonewton meter. Now let's go to this one. So let's go to section design to check the analysis results. Don't worry about this. We're not interested in this. We really want to check the moment and compare it with what you have in the textbook. So let's go to diagram. So the software is actually giving us a moment of 51.7, while the textbook is giving us 45.2. Now, the software is not over designing anything. I'm going to explain to you. I will explain to you. Now, let's go to calculator now. This one is what? 51.7, right? Minus 45 point what? Is it 45.2? Yes. That means the moment of the software is 51.7, while that of the textbook is what? 45.2, right? So we have 6.5. 6.5 now. Okay. For 6.5 now, let's now look at the difference in terms of percentage. Let's look at the difference in terms of percentage. You see that it is actually less than 0.15%. It's not even up to 0.2%. So let's say this thing. Let's say 45.2 times 0.1. So you have 4.52. So this thing we got 6 point. Sorry, I can't remember what we got. We have what? 51.7 minus 45.2. Okay, we have 6.5. Now let's say 45.2 times 0.15. Can you see? It's just around 0.15%. It's not even up to 0.2%. Now, let me now tell you the reason why I said that the software is not over designing. I have a spreadsheet here. For the beam. I think I made mention of this in my design video of the semi-detached. I can't really remember. Now, let's check for. Okay, let's go to the textbook. Let's check for what the moment of the textbook is. 45.2. Now let's design for 45.2 manually. Let's design for 45.2 manually. Now let's go to the spreadsheet now. So let's input 45. Now let's say this. So let's go to what? So let's change the moment to what? 45.2 now. This is what we have. Now for 45.2, if I want to design this beam manually, it's telling me that okay, it's actually 250, not 230. It's actually 250. Yes. So it's telling me that I need to provide a reinforcement of 330 square meter. This 330 millimeter squared. That is for the area of steel. Now for 330 area of steel, let's check for 12 mm now. let's say 3Y12 now. For 3Y12, for 12 mm, I'm having 339 mm squared, okay, which is okay. Now let's check for 51 point, I think 51, I can't remember. So what is telling us that just for 4Y12 can also work for 45.2 also. 4Y12 can also work for what? 45.2. Are we there? Can also work for 45.2, which is actually very, very okay. So the software, now, if I have a moment of 45 and I'm having an area of steel of 330, of course, I can provide a steel bar of 4Y12. Yes, I can provide 330, I have 4Y12. That is the next one that is higher than that. So the software is not over designing. It's not over designing. It is still the same number of reinforcements that is going to be provided for the textbook, which is what? 45.2. That is what is also going to be provided for this also. Now let's go to the second example. Let's go to the second example now. Let's go to the second example. Let's go to the second example. Now, okay, this one now. Now let's go to section design. Section design. Now let's go to diagram. Now, okay, very good. This is where we are now. This is where we are. So let's go to the textbook now. Let's check the textbook. Let's check the textbook. Let's check the textbook. Okay. Now, for the textbook now, the span reinforcement for A is 69.4, while for the software, the span reinforcement is what? 78.4. It doesn't now, the span reinforcement for this one is 112.5. This one is what? 121. Are we there? The span reinforcement here is 44. This one is 48. Can you see that the software is giving us things that are actually very, very close? It's not as if they're actually far off. The top reinforcement for this one is 112. Why? This one is 121. This one is 88. This one is 97. This one is what? 125. This one is what? 121. So it is still the same. Okay, let's try and check. Let's check. Let's go to the. Where's my Excel sheet? Okay, this is my Excel sheet. So let's input that of this one. We have what? We have let's pick 48 point. Okay, let's pick 78.4 for this. 78.4. So let's pick 78.4. Let's pick 78.4. So we have what? 611, which is what? Let's change this to 16 mm. So okay, I can't even use this in 3y16. So let me change this to 4y16, which is what? 804. Now let me make this what? So let's go to the textbook now. I think the textbook was 69 point what? 69.4. 69.4. Okay. So let's go to the textbook. Let's go to textbook is 69.4. Okay, very good. Now let's go to the Excel sheet. Let's make this 69, 69.4. 69.4 is 250. It's 9.4. So for this also, I can still provide the 4y16. 4y16. It doesn't mean that the software is over. The software is not over designed. The difference is we have a difference of like 0.15% compared to what we have in the manual design. But you can see that the moments are closed. This one is 48. The textbook is what? The textbook is what? 44. 44.01. And the software considers, I believe this one was also considered also, but the software, that is why if you know how to use PROTA Structure very, very well, you can't design a structure and you'll be scared that the software is actually going to fail. Never. So this one now, let's check the moment of this one. Let's check the moment of this one. So let's go to diagrams. This one is giving us a moment of 395. Now let's go to the textbook and let's see the difference. Let's see the difference. Let's see. Let's go. Let's go. Let's go. I think we got 382 for this. 382. 382. This one is 395. So the difference is not that much. The difference is not really that much. Yes. Sorry, this is not where I'm coming to. The difference is not that much. So you can see the closeness. You can see the closeness. You can see this. So, like I said, there is a difference of 0.15% between what we got on the textbook and what the software is actually providing. But when you take it to in terms of area of steel, you would still be getting the same thing. Because if you're providing maybe 4x16 for this, by the time you want to provide for what got in the software, you might necessarily also be providing 4y16 or 4y20.